Welcome back to another video with the Cauchy Euler method. Last video we just kind of found the general solutions and we deal with homogeneous equations. This video we are going to be dealing with non-homogeneous equations, and more particularly we're going to be focusing on finding the particular solution. So if you want to know how to solve the homogeneous portion of this part, feel free to check out the previous video. So let's go ahead and get started. And so the first one we've given the ODE x squared y double prime minus 4xy plus 6y is equal to x cubed, with the homogeneous portion of the solution being c1 x squared plus 2x cubed. And so right then and there we have our function being x cubed and it's in the homogeneous portion of the solution. So that means, if you recall in the previous video when we discussed about non-homogeneous equations, without using the Cauchy-Euler method, we multiplied everything by t. And so we multiplied by t raised to some power of s, where s is the lowest power, and we just carried on from there. But if you remember lecture, we made t be natural log of x. So that means instead of multiplying it by t, we'll be multiplying it by natural log of x and then raising it to some power s, where s is still the smallest non-negative integer. So in this case, our particular solution will just be equal to ax cubed times natural log of x. And so we just have to raise it to the first power because it will no longer be, no duplicates of the derivative will no longer be involved. And so this means that we also have to add, well, actually take that back. We multiply this by natural log of x, but it's ax cubed plus bx squared plus cx plus d, and then and so we simplify this a little bit further. So ax cubed plus bx squared plus cx natural log of x plus natural log of d natural log of x. And when we take the derivative, this will be 3. So this will be 3xa, or x squared, natural log of x plus ax squared plus b of x plus 2bx natural log of x plus c natural log of x plus c plus d over x. And then the second derivative will be 6ax natural log of x plus what I believe is 3ax plus, not a, 2ax plus b plus 2b natural log of x plus 2b plus c over x minus d over x squared. And so when we plug it in to the formula, or the original equation, I will run out of space. So we will be having already x squared. So this would be 6ax cubed natural log of x plus 3ax cubed, 5, actually it'll be 5ax cubed plus bx squared plus 2bx squared natural log of x. In this case it will be 3b plus 3b squared plus cx minus d minus 4 times x. So this would be minus 12x cubed natural log of x minus 4b cubed natural log of x minus 4cx squared natural log of x plus, not plus, minus 4, and I'm looking at the wrong one. Okay, hold up, I timed out. Okay, minus d. So this will be minus x cubed. Okay, yeah, I messed up the part here. So this will be minus 12x cubed natural log of x minus 4ax cubed minus 4bx squared minus 8bx squared natural log of x minus 4cx natural log of x minus 4cx plus minus 4dx plus, we have to multiply the 6, so multiplying the 6 will just be plus 6ax cubed natural log of x plus 6bx squared natural log of x plus 6c of x natural log of x plus 6d natural log of x. And that will be equal to x cubed. And so we can start canceling things out. For starters, what can we cancel out? The 6, I forgot this was multiplied times a, left out the a. So this part and this part cancels out because it'll be 6 plus 6 minus 12. Do the d's cancel out? Wow, I'm running out of space. Yeah, those cancel out, and we'll be left with 5ax cubed, so it'll be this one, and then minus 4ax cubed. So we're left with ax cubed equaling to x cubed. Well, actually, so it'll be plus the b's and the c's and all that and equal to x cubed. And since b, c, and d has nothing raised to the cube, then that means b is going to be the same as c, which is going to be the same as d, which is equal to 0, making a just being 1. And so our solution, let me actually move this to the, or not to the side, but out of the way. And then, so that means our solution will just be y is going to be equal to c1x squared plus c2x cubed plus x cubed natural log of x. So that is it for this one. And so now let's move on to the next one. So this one hopefully does not take longer than this. So we can see that x to the fourth is our function, is not in the solution. So that means we can let our particular solution to be in another color. So y of p will be ax to the fourth. So y prime will be 4x cubed, and then y double prime will be equal to 12ax squared. And plug it into the function, we will be getting 12ax to the fourth minus 12ax to the fourth plus 4ax to the fourth equaling to x to the fourth. These two cancel out, making a equaling to 1/4. So our solution, general solution, will be c1x squared plus c2x squared natural log of x plus x to the fourth over 4. And so for the last two, it's the same thing. We see that x to the 4/3 is not any solutions. So we let the particular solution be ax to the 4/3. And so the derivative will be equal to 4 over 3 ax to the 1/3. And then the second derivative will be not that. 4 over 9 ax to the negative 2/3. Negative 2/3. And so we just plug it in. So this will just pretty much be 16, because it'll be 4 times 4, 16 over 9, 8x, x squared. So squared is 6, so 6 minus 2, which would be 4/3, minus 4 times another 16 over 3, ax, this would be again also 4/3, plus 3 ax to the 4/3 is equal to 8x to the 4/3. So we can cancel out the 4/3, and so this just pretty much leaves us with a times 16 over 9 minus, multiplying both sides by 3, so 48 over 9 plus 27 over 9 is equal to 8. And so a will be equaling to negative 72. No. A times negative 5 nines. A is equal to 8. Or a is going to be equal to negative 72 over 5, giving us the general solution to being c1 x to the 1/2 plus c2 x to the 3/2 plus minus 72 over 5 x to the 4/3. And then our last example will be x squared, or this function, and then we have a trig solution. So our function is natural log of x, so we can just leave it as is. So our particular solution will just be a natural log of x, and so its derivative will be a over x, and then second derivative will be negative a over x squared. So putting it into the equation, we'll have negative a plus a natural log of x, and that is going to be equaling to natural log of x. These two cancel out, so a is just going to be equal to 1, making our particular solution, or general solution, being c1 cosine of natural log of x plus c2 sine of natural log of x plus natural log of x. And that will be it for this video, and this is it for all of the Cauchy Euler method. If you plug in, if you do initial conditions, well, it's just simply plug and chug. So yeah, that would be pretty much it for the Cauchy Euler method. First example took longer than it should, but I apologize. So yeah, that will be it, and I'll see you guys in the next video.